Sometimes in the encoding, there might be multiple chain of encodings. What I mean by chain of encoding is, let me take a simple example. So you can get this again from the resource section. So I'll just copy this one. You can check this out. And now if I paste in our input, the one that I have pasted, now look at this one. So based on the previous lecture that we have learned, what do you think this encoding is? Is it hexadecimal? No, because you can see there is later the capital Q and so on, so which is out of the range of hexadecimal. So we talked about the hexadecimal range. Now, clear cut, if you see the equal sign at the end, it is base 64. Always remember that. So that means I'm just going to go inside the favorites and I'll just from base 65, I'll just copy this from base 65, I'll paste it right here. Now again, after doing from base 64, I got another encodings. I did not get flag. So I got another encodings that looks something like hexadecimal now. See here, it ranges from 9, that is 0 to 9, and the letter is A to F. So that means you can see this is hexadecimal code. So here on top of base 64, I'm going to convert from hex now. Now we got the flag. So see, we got the chain of encodings here. So this is the use case that we typically have in our real world challenges. We will have chain of encodings and we need to do chain of encodings to get the flag. So here we got only 2 encodings to be chained, but maybe there will be 3, 4 and 5 sometimes, but that is rare case. But at least there will be 2 and 3 encodings for you to work. Just remember the range, that will be enough. If it ends with equal sign, base 64, and that is enough. So I'll just clear our recipe now for now. I'll just grab the next one in our challenges, which is this big sets of numbers. Let me copy them. Now you can see it is the combination of zeros and ones. Now, as we have learned, the combination of zeros and ones are nothing but the binary. So I'll just close these favorites. I'll go in the data formats because here is where we will get our binary. So this is not 2 binary because I don't want to convert to binary, but I have already binary. So from binary. So I'll just get from binary. Now you can see again the numbers instead of a flag. So these numbers look smaller. They are not binary obviously now because they are not the combination of zeros and ones, but they are numbers. So for numbers there are 2 cases. Either they will be octal or they will be decimal. If it has to be decimal, it has to be a lower number. If it has to be the octal, it has to be a higher number, maybe near to 150 and so on. Now they are small numbers, that is below 150. So that means they are decimal. So I'll just get from decimal now. So I'll just grab from decimal. Now again we got encodings instead of flag. Now this encodings looks something like hexadecimal. You can see this has not only a numbers. If it was only a numbers, this would be again the decimal. But this is a combination of numbers and these alphabetical letters. You can see here C is there, D is there, and so on. Now if there is a letters and alphabetical letters combined, alphabetical letters and the number, that has to be a hex. So I'll just grab from hex. Now finally we got the flag. Now this is the real world use case to capture the flag. Now you need to understand this, you need to understand the range. Just come to this website and do the decoding for your ciphertext. So that is all in this video.